so much. All right. So yeah, I think that sounds good. So feel free to go on in your own page and talk about your stuff that you're working on.
Cool. Yeah. All right. Let me. Oh, okay. So I'm trying to share my screen. There might be like a button that you have to press.
I
I don't know if it lets. It's
yeah,
just saying like this.
double check now.
Okay, cool. Nice. Okay, cool. Can you guys see this?
Yeah.
Nice. All right. So I'll just do a quick introduction. So, right. So what is it that we do here, right? At IBM Quantum, quick introduction, guys. Hi, I'm Ryan. I work on our quantum compute software stack at IBM Quantum. So what do we do, right? There's really two pieces. One is we want to bring quantum computing, but useful quantum computing. Something that would outperform some task you could do on a classical computer. And the second piece there is, well, once we have that technology, we also want to lock it down. Just make sure that we are, we have both ebb and flow there, right? Because there's, to some extent, there's some implication, right? If you have this high powered computing, you also just want to make sure you have the security infrastructure for it. And that comes in a bunch of ways, right? And in terms of right career paths and things like that, there's a lot of things that make that flywheel go. There is everything from hardware components, right? Whether they're quantum hardware or just normal system hardware that make that possible. There are software teams, right, to develop the backend, a long stock of backend services between some user, right, and then the quantum computer itself, right. There's product teams that talk to people interested in this kind of compute and some tasks that it could help solve today. There's sort of a bunch of things that sort of just make that whole process happen. And yeah, so then where do you see this come up, right? Quantum computing as a whole. And there's really three paths. One is things like drug discovery, things that have chemical processes, right? You want to when you're simulating organic systems, there's a lot of parts about a quantum computer that are beneficial, right? Because the problem space is more native to how a quantum computer calculates, or quote unquote calculates. And machine learning, right? So what we're trying to do is apply this compute in a similar way to, we're trying to map this, this style of compute to problem spaces in the machine learning world for potentially all sorts of benefits. If we could expedite the training process, if we could unlock different ways to do that calculation, right? It's an active area of research and an active area of development. And so you can see there's just kind of different, and then optimization, sort of the same deal. We have these classical problems, right? You guys are probably taking algorithms classes, for several things on this page. And really what we're trying to do is say, hey, we have these problems that exist in classical compute. And we have this different way to do compute, right? And these are very valuable problems to solve. And they're very expensive problems to solve. So how can we do our best to find ways that we can dramatically change how these problems are calculated? And that could have substantial impacts, for large businesses and for people, countries, organizations, straight down the line. There are a lot of impacts that you could do if you could expedite these problems, the way that quantum as a whole is looking to do. And then, right, yeah. So when you're talking about careers, right, like what does that look like? And kind of what I was talking about earlier is, I think a lot of times when you think about like what is quantum compute, you kind of think about like a researcher in a lab, right? Somebody that's or a physician, right? Somebody that's really, really hands-on, problems on a whiteboard or a chalkboard, probably. And there's really a lot more to the equation than just that, right? We have all sorts of developers, right? We have people that make content educating people is a big piece of the job right now, because we, in addition to just solving these problems, the more people know about the space itself, the better people come into the industry, right? And they bring new insights, and the industry expedites, right? It moves faster. So there's a lot of learning work that we do. And there are entire teams of people that do things like that, right? There's entire teams of people dedicated to software testing, architecture, dealing, interacting with the community, all sorts of things, right? And so there's a lot of pieces to the puzzle that aren't necessarily software, aren't necessarily, physics or very, highly research related. But obviously those are a core piece too. And then just, yeah, like where do I fit into the puzzle? Just to give some context about me. So there's a few ways that you can consume quantum compute, right, from IBM. And one of the main ways is if you go onto the site. I don't know if, maybe you see this in like quantum classes or something like that, but we have this site, and you can run quantum jobs, right? You can send them through Qiskit, you can send them through the circuit composer. And this is the platform. So I work primarily in our backend service stack to deal with like the quantum circuit job execution flow. But it's primarily for this product. So I came in as an intern. This was 2 years ago. I came in as an intern. There are a lot of, from our internship perspective, like there's definitely a lot of ways that you can, a lot of opportunities, right? So like they have like these fireside chats with people in different parts of the organization. You get mentorship, and you get really close to your mentors. And sort of, through things like that, and some of just the resources available, really enjoyed it, learned a ton, and I can talk more on that. And so this is the product I was working on in my internship. Came back, started last year, and this is what I'm currently doing. And then I'm sure that there's probably all sorts of questions, but this is the last slide I've got.
Yeah, thank you so much. That's like really exciting what you're doing. And I'll start with questions, I guess, many people addressed, like wanted to hear answers on is, so as a person who's working in the field itself, what do you think the perspectives and the future of quantum, and what is the time scale when you think the next so-called quantum revolution might happen? Can we expect it to be in the nearest future, or how much work do you think we have left, and what are the main areas where we will have breakthroughs?
Okay, that's a big one. Okay, so I'll chop that into smaller pieces. But it's a great question. It's a great question. So, where is quantum at? It is in the shaping of a product phase from a highly research and development phase. So for the past, I'd call it 6 years, up until, maybe the past 6 to 12 months, I'd probably say that the quantum compute industry as a whole was pretty much entirely R&D. Computers were not tremendously large, and the problem domains that they could solve were fairly small. I think that some of that has changed in the fact that we now have devices that are very modular, right? There's a lot more modularity in devices that have been made this year, and devices that are going to be made in the next couple of years, which is going to, and then there's sort of been a few other things like, techniques like circuit knitting, that are showing a lot of promise for growing bigger quantum systems. That's really important, because when you talk about like where is quantum computing, it's a lot of it is down to how big of a system you have and how good of a system you have. Because generally speaking, a lot of problems can be solved. I mean, like from a theoretical perspective, a lot of problems can be solved if you have, a perfect, no noise, logic 10,000 logical qubit computer. I feel like in most of the papers that talk about like breaking cryptography, some of those smaller hashing algorithms, that is usually what's cited, but that is very difficult from a quantum systems perspective. So where our systems are now is starting to break. I mean, that's kind of the peak of utility. Where are our systems now? We're starting to break into a domain where we can see a little bit of utility. When you hit somewhere around 100 qubits and a little more than that, you can start to solve some interesting problems. And I guess forecasting the future beyond this year, next year, it would more so depend on the quality of the quantum systems that come out than it would, maybe the algorithm side of the house. Or yeah, I mean, I'm sure there's a lot of factors, but I do know it's very dependent right now on the quality and the size of our systems, and that's one of those big focal points right now.
All right, thank you so much. Does anyone from the audience want to ask a question? Yeah, I think you raised the hand first.
What school did Ryan go to?
Yeah, so I went to the University of Rochester in Rochester, New York.
Yeah, could you, by the way, elaborate a little bit more on like what background did you have before coming to quantum computing and IBM particularly? Did you do some internship or research in this area in college, or did you just jump straight into that?
Sure. So I walked in and I'm currently mostly on the software side of the house. So when I actually had first applied to quantum computing, and I'll go back a little bit more, but when I had first applied to this position, I had taken a class in quantum, like an introductory class in quantum computing, but I didn't have I really didn't have much background at all. What I had done before that, which more translated to my role, was just some software experience. So before that, I worked mostly at like startups. I had worked more in small software environments. I'd done things like hackathons, things like that. But a big focal point was just projects that were mostly outside of like the bounds of school. Things like, hackathon projects, startup experience, things like that were mostly what I had done. And the reason I think that was something that was interesting to, whomever was hiring me, like, my former manager and the hiring manager at the time, was because quantum computing at most companies has been growing quickly, but is very new. I mean, I think our quantum practice is only like 5-6 years old. And so it has in the past few years made the transition from a startup, like a small lean up startup environment, to a more developed business. But that was kind of where I came in from.
That's awesome. Thank you so much. Do you have a question too?
Yeah, so I'm kind of like a noob, and so I have no idea about like what quantum computing is. So if you could like maybe like explain what quantum computing is and like how it's different from like normal computing and like what its applications are.
Yeah, sure. So I guess quantum computing, generally speaking, is just a different way to, I guess quantum computing is in essence, we're just trying to map a an atom, right? We're trying to take the properties of an atom and leverage, right, some of those pieces into information. We're trying to take some of the parts of that as a whole, right? You know, its angle, right? Its spin, its position in time, and use those as properties to do calculations, so we can store information in more dimensions than, like, you know, a one and a zero would be, right? So we our basic unit of calculation, like a quote unquote qubit, we have properties for it that are a little bit more than just a one or a zero, right? We have the spin associated with it. There are properties like you know, they can entangle with each other. There are properties to it that are a little bit more expressive than just the traditional run of the mill classical computer, I guess, is what makes it a little bit interesting. And so what I guess the second piece of your question, I don't think I caught.
Like what are the applications of quantum computing?
Sure. I mean, I guess generally speaking, they're the applications of computing. You know, well, all we're really trying to do is say, hey, here's a domain that we have solutions. Or here's a, right, this is a domain of problems. And for large compute, right, where it makes sense, right, you know, these are a domain of problems that people are solving at scale. And generally speaking, they would be of scale, because if you want a problem that makes sense to solve on a really large, expensive computer, it would be something like that. And we just want to say, well, this is a problem that we're solving with this kind of computer. We can probably solve it a little bit better on this kind of computer, right? But they're not fundamentally different than any problem you'd really want to solve on it with a classical computer, right? You break down to big machine learning problems, big optimization problems, you know, like big search space problems, things that you can solve. A lot have to do with randomization. A lot of stuff you'll see in like your AI class, and institutions that are mostly doing these things are like mostly financial institutions and like big data companies and things like that.
I'll also recall that I guess quantum is better at simulating chemical systems, like way better, promised to be way better than classical. Am I right?
Yeah. And the general idea there is that we need to, right, because I mean, a computer itself is more or less simulating. What you do with a simulator is you try to replicate that environment that is inherently quantum, right? So you need 2 to the n bits to simulate a problem of size n. And so obviously, when you're working with a quantum system that is inherently that environment, you only need n, right? And so when you're talking about something like chemicals, because that's really, we use qubits, right? But all they are, you know, protons, electrons, and so the system is that inherently, and so you don't need to make that mapping. And so something that is that is very computationally expensive on a classical computer, just it isn't on a quantum computer. The computer itself is way more expensive, but the problem, you know, the individual problem is not. It's substantially cheaper.
Makes sense. Thank you. Yep.
In terms of like internships, I know people tend to get internships like later, like end of like summer of sophomore year and summer of junior year. But if I'm a freshman, is there any, like, what are the expected like prerequisites to get an internship for like IBM Quantum?
Sure. Generally speaking, good question. Generally speaking, it is to do, there's no prerequisites, right? You can come in at any year. Um, it depends on what you're doing, right? Because for certain positions, there's a little bit different an expectation than other positions, right? I mean, there's the software space, there's the product space, there's like the content design, and then there's also really, deep diving research. And so in that last one, the expectation is probably something more on like the PhD track. With many of the others, that's not the expectation. The expectation is mostly just to have a little bit of experience or insight into the piece of the puzzle that you're looking to fit into, right? So if you're looking to get an internship in like the software space or with one of the software teams, I think the big thing that you would just kind of want to have reflected on your resume is, hey, these are probably some problems that you guys are solving, right? Maybe it's, let's say, like backend services. So there's some of the stuff that I work on, right? So like let's say you guys are doing backend services. I've made a backend service. I've seen it end to end, right? So I've seen it start to finish. It's seen the light of day. We had these challenges. It wasn't. It has a lot of good, right? It had users, right? It saw a little bit of scale. There were challenges along the way, and this is how I addressed them, yada yada. But that stuff's really important because one, the first piece is when anyone's like looking at your resume or anything like that, the first question would be, oh, so this is what we do on the team. Does he have a little bit of experience doing that? And then you check that box, like, oh yeah, he's built this, right? It's a backend service or something like that. And then, over the course of the interview or something like that, it's definitely beneficial to be like, hey, when I was developing this, there's a bit of a story to it, right? There were highs, there were lows. When we hit the lows, this is how we solved it. This is how we addressed it, right? Not everything's perfect, day to day, especially in the quantum industry, right? It changes probably 15% every year. And so that's an expectation, right? Anyone interviewing is going to know that. They're like, yeah, we have, there's all sorts of things that come up. We're like, hey, we have a challenge scaling this. We have a challenge developing this, whatever. But I think that's really valuable stuff to have reflected in your, like through the interview process, in the resume. Yeah, I'd probably say.
Great, thank you so much.
It's helpful.
I have you can hear me, right?
Yeah.
Okay. I just had a similar question to him regarding the getting in, but mine was more on the hardware side. I originally came here for electrical engineering and material science for the purpose of building quantum computers, specifically for the biomedical field of personalized disease cures. I was just curious to know how I can actually get involved in the research and internships to try and make that happen for building smaller, faster, more efficient machines to make these algorithms useful.
Yeah. Could you real quick repeat the question?
How do I get involved? Who do I reach out to? And
Sure. Yeah. So yeah, good question. So the first piece is one, just knowing with a little bit of granularity, this is the problem space I'm looking to get involved in. So you were saying hardware. The first question, like just to split that into two, the first question that I would say is, are you interested in quantum hardware? Are you interested in classical hardware? The second step would mostly be, in the hardware space, if you were looking more to stay in the research side of the house, there's going to be a lot of publication on that. Some of it, I mean, in terms of hardware, right? Some people are working on theory, and some people are working on, just the application, the development side of things. But if you're talking about staying on the theoretical side of hardware, there's going to be a lot of people that are publishing papers. From that, right? Check them out, right? Check them out and say, hey, this is something you guys are doing. It's really interesting to me. There's going to be names on the paper, right? There's probably going to be companies in the paper. And so if you see that, those are great starting points. you know, someone probably spends God knows how long, probably 6-8 months writing a paper. It's probably going to be really something they're extremely interested in talking about, right? I mean, it's a time commitment for them. And I'm sure that they're gonna love the opportunity to just talk about it a little more.
Great. I also want to add from myself, you can join our club. That's also a great start.
I was gonna ask about that. Well, yes,
Yeah, you can talk to me after the meeting. Yeah. All right, thank you.
Thank you.
Honey?
So, do you know any other companies or maybe colleges that you collaborate with on maybe not even on a daily basis, but like weekly or monthly, that you could also share the more opportunities maybe?
Yeah, so I know that my first answer would be I may not be the best point of contact for that question. But I know that we have a very close relationship with RPI, with Columbia, with the University of Chicago, with MIT, and I want to say the University of Tokyo. Generally speaking, I don't have a great answer for that question, but those are ones off the top of my head that I'd be able to say.
Sure. Another question, what are some of the challenges on the software side, like some of the more, I guess, relevant challenges that you're facing, like in general on the software side?
Yeah, sure. So I would probably say two things. The first thing is scale. The systems get bigger, right? I mean, like it goes without saying, right? The systems get bigger, the payloads get bigger. There are certain things that you can do some ways that make a lot of sense this year that the landscape will change a little bit for next year. And then maybe it doesn't make as much sense. Scale is one of them, no doubt. The second one, which is probably the more important of the two, is it's like I was saying. I mean, quantum computing as a cloud service is probably 5-6 years old, maybe a little older than that, but it's very new. And so every year, how we've thought about it changes, 15, 16, it changes a little bit, right? And so how we think about those problems across the board changes. For example, I guess a good example would be we have, when we first started as a business, we said, okay, we're gonna allow people to run quantum compute, and we expect they're just gonna have a job, right? And they're gonna send it back to us. It's gonna go through whatever. It's gonna hit the quantum computer. It's gonna come back. They're gonna have that result. So then over time, about, I don't know, 2-3 years ago, we said, well, the way that we see quantum compute going now is a little bit different than that. We probably expect that most people are interchanging quantum and classical compute with most of their jobs, right? Anything interesting. And then a little bit later, right, we gathered data, we spoke to people, and we said, okay, we're absolutely certain the way that people are solving problems using quantum compute today is they have some classical compute, right? So for example, you have a machine learning algorithm and you're going to say, I want this done in quantum compute, right? And then I have this part, right? We're going to update some parameters. We're going to make some changes. And then I want it going back to the quantum computer. So we changed that, right? We said, well, it doesn't make a lot of sense to have some person with their laptop. They send us the quantum circuit, and then they have this constant back and forth, right, between them and this quantum computer that's sitting somewhere. So we invented this theory of this concept of runtime programs. So there's just a cloud program, right, a Python program sitting somewhere, and this whole calculation is they just send some information up, and that program itself and the quantum computer just a back and forth. and then it's self-updating, and at the very end, when it's all done, they'll get the result back. And so you see between that and just sort of between some other things, there's just a lot of software components that change.
So a lot of the opportunities seem like back end type stuff, dealing with the consumer, communicating with the computer.
It's yeah, I'm sure, like it's a long back end stack, and it goes from more quantum to less quantum, depending on where you sit with it. There's a lot of I guess front end involved to some extent, right? I mean, we have a learning platform, we have the IBM quantum, web page. Like there is front end work, but I think generally speaking, we're probably 75-80% back end work. And because the core of our business, right, is delivering this compute framework.
Thank you.
Much. I think you were. Yeah, you.
Yeah, okay, cool. So I'm also a complete noob, so this question might seem a little, I hope it's not a bad question.
There are no bad questions.
No, you're good.
I guess, where do you see the future of quantum, in terms of like next generation, and like, will there be a point in the future where I'm not carrying on a regular computer, a quantum computer for any reason? I mean, the way you described it seems very specific to certain problems, but I guess will quantum evolve to a point where it can solve more minute problems, and then I'll be able to solve more big problems with it,
Yeah, no, look, it's a very good, very fair question. Generally speaking, I wouldn't be able. Generally speaking, I don't know. The tail end of that question, right? Are quantum computers going to replace the computer that you open up when you're at class? No. A quantum computer is going to be pretty specialized. You're going to use it to solve. Just kind of like certain classes of cloud problems, and problems that you would solve using a cloud computer, because you realistically won't have a quantum computer sitting in your room or desk or anything like that. Now the compute will probably get substantially less expensive, right? The same way a lot of things do. But generally speaking, you'll see it in most areas of like computer science problems. I do probably envision. That's probably where I see the future, generally speaking. But it changes a lot. I mean, it's hard to give that one a firm answer. But it's a very good, very fair question.
Thank you.
Thank you.
Yeah, so what would you say takes up most of your time, or that you spend most of your time doing? Is it like debugging the stuff you've already done, or like planning ahead for how you might change things, or what?
Sure, yeah. So most of the time is probably spent, I mean, generally speaking, you have these meta goals. So something, a lot of times it will be a system. So for example, the one we released at our last, we have a summit coming up in a few weeks, which a lot of people are doing a lot of work to prepare for. But at the summit last year, that's when we unveiled like our newest, biggest computer. And the preparation for that was substantial, because we hadn't dealt with scale that way. And we're a unique industry in having certain classes of problems. So the day-to-day around that was, well, where are our weak points in the software stack for scale, right? And there's certain very specific challenges, right? One would be our Python SDK, Qiskit. I mean, it's publicly available. You can download it on your laptop today. You can run a quantum circuit today. So it's something that people have locally on their laptops, which means you can't expect it from a backend perspective. You can't expect it to change. And so like you need to be extremely backwards compatible. So it brings some challenges, right? How can you change to support certain scale? but also support a lot of backend compatibility. And so your day-to-day can be, well, we have this problem. You sit in a room together and you say, how are we going to figure that one out? And then, yeah, I mean, here and there, right, things will come up. You say, hey, like, we have to tweak this, right? Or we have to fix this or something like that. But generally, it'll just be surrounding some big goal. So I know a lot of people from the research side of the house, from all sorts of part of the business, are doing things right now just in preparation for the summit event that's coming up in a few weeks. And that's probably the best answer I would be able to give for that one. I don't know if that answered your question.
Yeah, it does. I did have another question, maybe
Yeah, shoot.
the summit, but do you know of any other like services or products that IBM is working on currently other than the website that you do?
Sure. So we actually have like a roadmap published on, let me see if I can check it out. But we have, I mean, IBM is a publicly traded company, so you can generally speaking, you can kind of see that vision. But if you look up, right, our development roadmap, you could see, the path forward, right? And a lot of it is surrounding the people, right, the adopters that we expect, right? People that work in machine learning, we want to give them modules to work with. We want to make it easy. People solving finance problems, right? Portfolio optimization, things like that. So we have sort of domains and our ideas, right? We want to be able to, one, build a foundation, right, for people from their companies that are doing this kind of research. And then two is the longer term piece there. We would like to be able to have this, right, put a bow on it and be able to sell that. And so you can Google it, you can type it in, just see the trajectory from, and it's got the system that we expect to be available, the kernels we expect to be available, the things that you can just load up the website and then use out of the gate.
Thank you. I don't know if we have space for one more question. Yeah.
So before you said that IBM was doing a lot of product development with your cloud quantum computing, but I was wondering if there's also like a software component focusing on like new quantum algorithms.
Sure. Yeah. I mean, that's a big piece. So part of the business is really overseeing the management of Qiskit. So those people work very hand in hand with, I mean, a good portion of them are doing active research, and there's teams of people doing active research. There's like the theoretical pieces of quantum computing development and algorithm development, and then there's the people that work on the Qiskit side of the house to put that into the hands of whomever. And so there are people working on the theory there, and then there are people working on the application there. And the application is Qiskit, just developing Qiskit modules and functions that will do that. But there definitely are people doing the actual development, algorithm development, and research.
All right, thank you. Are there any final questions from the audience? Yeah.
If you use AI like in your everyday like work day, and like if so, like how do you use it?
Yeah, that's a good question. So AI is used in a lot of our software components. I wouldn't necessarily say I use it in my day-to-day, but AI is used very thoroughly in our software stack, in our general software stack. We have AI components to do lots of things. Many surround just the protection of the application itself. But there are lots of features related to job execution, like circuit job execution. security. I'll try to think some more, but there are a lot of people that work in the software part of the organization. I've worked a little bit on some of those products, but there are a lot of people that work in our software organization only on the software stack that exclusively do machine learning engineering, because that's a big piece of getting things right. A lot of the times, it can help progress the stack as a whole a lot.
All right, thank you. And I don't know if we have room for one more question. I have one.
Sure.
I promise it's the last one. So I'm a physics major and I'm really interested in quantum computing, but I don't know if you can relate to that from software perspective. What are your thoughts of academia versus industry for quantum computing?
Sure. I mean, I guess it just depends on what you're looking to do. What you're looking to get out of it. I would probably say that there's, there are certain things there are certain boxes we're looking to check, right, in the industry for the problems we want to solve. We see optimization, we see different machine learning problems, we see certain organic chemistry problems, and we say, we've identified those as problems that we're interested in solving with a quantum computer. And so there's a lot of creative freedom there, but there may not be as much creative freedom as you see in an academic environment. So for example, if you were to work in academia, you probably have a little bit wider a net that you could go fish out of. But if you do it in industry, there some advantages might be you might have more infrastructure, you might have more resources, a little bit better, funding, depending on where you're doing it, what you're doing. But the trade-off there is that at the end of the day, you're looking to potentially sell something or to have that reap some reward. Whereas in academia, you might be able to have that incentive be different.
Yeah, that makes sense. Thank you so much. Do you have any final advices for the folks in here that you want to share?
No, not at all. I would probably say one thing is, if you do end up applying for things, right? Internship positions, full-time positions. By the way, our internship program has applications open right now. You should definitely go check out. But if you do find yourself interested in something, I would say a good idea is to just kind of have in your mind what piece of the puzzle you want to fit into. Because like I was saying, there's quite a few positions. And so the better of an understanding you have of what it is you'd like to do, and how your experience fits that bill, you're definitely, I would say that's definitely a very strong thing to go into the interview process with. Because it is nice having your eggs in a bunch of baskets, but at the end of the day, whether it's here, whether it's wherever, I would say at the end of the day, really, you're going to get hired in particular for one team. And so whichever team it is you're looking to work with, that would be the team that you'd want to gear your experience around.
Yeah, thank you so much. And it was really great to have you here today. I'm pretty sure all of us learned a lot. And yeah, it was really nice to have you tonight. And I hope you have a great night. And thank you everybody for coming.
Thank you guys so much. This has been great.
Thank you. Have a great night.
All right. Take care, guys.
Bye-bye.